We just finished unit 7. So again, I mentioned that's like the hardest unit all year. So with that, your grade, you'll know that your new test score has been updated. I always put the higher in the test scores. So you'll know that it is final when it says retake given during class time, higher 2 scores given. So hopefully I'll get that in today. Constructed responses do take longer to grade, but hopefully those will be in soon. Because I want you to have time to, if you need a third retake or a second retake technically, but if you need a third attempt on that test, that you have time to prepare for it, to come into Tuesday tutoring, because there's only 2 Tuesdays left. We're really close to the end. So that's why I wanted to finish unit 7 early so that you have that time. From the few constructed responses that I've graded, they weren't much of an improvement. Why? I really don't know. Like, I don't usually do this, but for this unit, I put the constructed response practice test fully completed in Schoology. So in this week's folder, annotated notes, and a lot of the tests ask you like, why is this a good method? Why is that a bad method? The reasons why aren't really changing. All that's changing is the number. So I really don't know why like we've still got number 1 wrong some people. When like the reason it's not reliable is the same from the practice test. You just have to memorize it, change the numbers. Really it. Same with like number 2. Some people still didn't listen. It's supposed to be a factored expression. You're not just putting in a random number for B. All right. But these are things that would be easy to fix. You just have to now come to tutoring. This one I think nobody should have gotten wrong because either solve it by graphing or quadratic formula. We did a lot of examples like that before. But these are easy to like review, fix during tutoring, and get points back. And that's a good chunk of points. Like if you got a 0 on your constructed response portion and you come in and do corrections, you can get a 25 out of 50, or you could retake it for full points. So there's still room to improve your grade, is what I'm saying. Now you just have to come to tutoring because I gave you a retake. All right, so there's that. But overall, I did see a lot of improvement on the multiple choice part, so good job there. And now we're doing stuff from unit 3, which was a unit we skipped first semester because we had to make sure we have enough time for the hard stuff. So one other thing I want to show you in here. Upcoming assessments and deadlines. Here's basically for the rest of the year, including final exam. All right, if anything needs to be updated, it'll be updated in the slides. But yeah, I have the last Saturday Academy date, which is the 13th. Deadline for retakes, all that stuff. When you're taking your final exams, all that stuff. So really in the home stretch. Questions? Okay, so like I mentioned, this is from unit 3, which is 2 variable statistics. So I think it's really important. When I was in college, and I get it, not all of you are going to go into like a STEM field, but when I was in college, literally every single lab class that I had to take, it was all statistics. And I think that out of all the things that I teach in Algebra 1-2, I think that this unit is really like the most valuable. Because again, in college, literally every single lab that we did had these components in it. So just consider that this is like real world applicable stuff. And it's also not that difficult in my opinion. So that's why I still wanted to do some lessons from this unit. I'll still give you a quiz on it. And it hopefully you should bring up your grade because again, kids tend to do well on this unit. And we're starting with two-way frequency tables. So some of this might be reviewed from science, but here it is. We have categorical data and frequency. So some vocab here for you. Quantitative data is data that can be expressed with numerical measurements. So what are some things that you can measure and it's numbers? Height. What else? Weight. Anything that's a number. Time. Anything that when you measure it, it's a number, it's quantitative data. Categorical data, also sometimes called qualitative. So quantitative versus qualitative. Qualitative would be like qualities or data that cannot be expressed using numbers. So not be expressed using numbers. Like animal types, model of car, favorite song. What else could be categorical data? Right, so give me other examples of categorical data. Color. Anything else?
Food.
A sport. Favorite food. So anything that you could gather that is not numbers. Maybe you're asking your classmates questions about themselves, like about colors or favorite foods. Those would be qualitative because they don't use numbers. All right, frequency table. What's another word for frequency? Often. So it's how often something occurs in categorical data. So yeah, when we make frequency tables, we do use numbers, but it's essentially just saying how many times something appeared in that data. All right, so frequency tables, pretty important. We'll do some examples with that. Any questions on the vocab? All right, so then look at these 3 examples. See what you can fill in just based off of that little bit of information. So determine from that list, which is the categorical data. Classify this data as either categorical or quantitative, and then complete the frequency table. So do that within your groups. I'll give you about 3 minutes. Okay, table 1, example 1. Which one is the categorical data? Color. You guys did happen to say it earlier when we went over the vocab, but you know, it is what it is. That's the one. My first hour said like some more funny responses, right? You know, that were different than like what's down here. But as long as you understand, categorical means not a number. So is there any other categorical data?
No.
No, the rest are all numbers. Temperature, weight, height. Good.
Yes.
So then table 2, example 2, large, medium, small. Is that an example of categorical or quantitative? All right, anyone disagree? All right, well, there you go. It is right. Table 3, what about 120 feet squared, 130 feet squared, 140 feet squared? That's an example of quantitative. Questions, comments, concerns? All right. So frequency tables now. Table 3, what goes here where my mouse is? Oh, sorry, I didn't realize I called the same table. That's okay. 7, table 4, what goes here where my mouse is? And table 5, what goes here where my mouse is? 5. All right, anyone disagree with those? All right, so this would be what we call a one-way frequency table. We'll be looking at two-way frequency tables down below. But essentially, the only way that I see students get this wrong is they forget a data. So like, not all the time, but usually in the description, it'll say Bob surveyed 20 students or whatever about how they get to school. You want to make sure that the numbers in your frequency table add up to how many people were surveyed. Landon?
There's something else.
Okay, we'll get this way, and then if not, we're not. All right, but over here, again, if in case anyone didn't know where they got 8, they counted 1, 2, 3, 4, 5, 6, 7, 8. That's how many people took the bus. For the car, same thing. They went in and counted 1, 2, 3, 4, 5, 6, 7. And then walk. I'm glad that we put it where the category is. That's the other method that they went. So good. And then 5 people said that one. And this one, it didn't say how many people they surveyed, but how many people total did they survey? 20. All right, so you want to make sure that your frequency table adds up to however many data points you have. And if you go back, there are 20 data points. So questions on that? Yes. So then scrolling down. Now let's talk about two-way frequency tables. We have some spots to fill in, some vocab. So a two-way frequency table is a frequency table which has data for 2 categorical variables listed as paired values. So in this example down here, first you're going to need to fix this. Every year I forget to fix this. They only surveyed 9th and 10th graders. They didn't survey 11th graders. What should go in this table down here is total. And then hopefully now it makes sense. Sorry. For that one at least. I think the rest are fine. But we have a high school's administration asked 100 randomly selected students in 9th and 10th grade about what fruit they like best. And we're completing the table, making sure we know the difference between row totals, column totals, and grand totals. So what direction do rows go? Left to right. So you need to write that, go ahead. And then columns go up and down. And what do you think it means by grand total? So it is your bottom right. At least sometimes I have seen on tests where they don't have rows or columns for the totals. But if they do, then that bottom right corner would be your grand total. Which in other words, what would be my grand total for this one? Anyone know? What would be my grand total for this table? 100. That I know even without filling in these parts, because it did say it up here that they surveyed 100 people. So that should be your grand total. In other words, it's the number of people or whatever they do. The number of people surveyed should be your grand total. Okay. And then the rest, hopefully you could fill in. So what's my row total for the 9th grade? 54. 54. So what are you having to do to figure that out? Add the total 9th graders that were surveyed, right? They put it in this data table. If I want to know how many 9th graders were surveyed, I just add up these values. And then how many 10th graders were surveyed? Okay, good. How could you figure that out? You could add up the row, or how else could you figure it out? Subtract the 54 from 100. Cause if we only surveyed 9th and 10th graders, and 54 of them were 9th graders, then 46 of them must be 10th graders. Does that make sense? Okay. And then down here, how many people, so 9th and 10th graders combined, how many people like apples? Sorry, what was that? 41. So in this case, when it's a column total, that goes up and down, add up and down. How many people chose oranges? 21. And how many people chose bananas? All right, easy enough. It seems like silly almost that we're doing this at the end, but like, I think it's important. We'll see. Questions on filling in the table? So what I think you're more likely to see on a test is either a table that's completely blank and you have to fill it in from scratch, like from reading the paragraph and filling in the missing parts. Or they might have it with some missing parts, like kind of randomly, and you fill it in. So let's do this one together. So looking at this, it doesn't give me really any description. It's just you read the table. It looks like we're comparing gender versus whether or not you eat cereal for breakfast. So very important stuff in this. What is something that I can fill in with my given information? The total for which one? 12 plus 10, which is, so these are people that said no. That's something I can fill out with this given information. There's something else too that you could have filled out right off the bat, which is the voice total. So even though I'm missing this, at least for right now, how do I know what goes here? Because if there's 54 girls surveyed, 100 people surveyed total, right? This is my grand total down here. Then that must mean we surveyed 46 boys. And then the rest, it's kind of like works off of that. Now you have more that you can fill in because you could figure out those parts. So like how many boys said yes to eating cereal for breakfast? And how many people said yes total? And then to make sure you did it right, like I could make sure, okay, the 78 plus 22 add up to 100. And vice versa, like this 36 plus 10 add up to 46 and all that good stuff. So if something's not making sense, then you probably messed up somewhere. So it's kind of like questions there. All right, then try. I don't know that we need to do all of these. Do B and C for sure. Sorry, if you, I mean, I can show you all of them, but B and C for sure I'd like you to try just because the reading that they have. So B and C will be the you try. And then so then compare your answers for B and C to what I have on the screen. All right, reason I focus more on these two, and really A kind of similar, but I like that in the instructions, there's some details because usually on a test when kids are like, this isn't adding up or whatever, I'm like, well, reread the problem. So there's some details in the instructions that of course would make it easier to figure out the rest. So any grand totals that they give me, like number of students surveyed, I would put that first. Like they said, 100 students were asked what foods they chose at lunch. So I'm gonna put the 100 there first. And then I can work backwards. I could minus the 49 to get the boys that were surveyed. I could, now that I know how many boys were surveyed, figure out how many had to have chosen apples. So this one was more like subtraction, honestly. So 49 minus these gives me how many girls chose apples and all that stuff. Now I can add these. And these, you can probably do those right off the bat. Questions on that? Making sense? So then, and then same for C, check your answers for C. So if on the test it says, how many boys prefer the projector? What would you say? How many boys prefer the projector? 57. So can we read a table is the other part that you need to be able to do. Or if they said, how many students prefer the projector? What would you say? Good, because students would be boys and girls, right? So you also have to like know that. Questions on that? And okay, so good on there. You still have trouble, let me know. But here's more, I'll say important stuff. So this is more likely what they'll ask. So relative frequency is more likely something that would show up versus just having you fill out a table. Usually they have you fill out a table and then ask you about the relative frequency. So when you hear the phrase relative frequency, you should automatically be thinking of decimals or percentages. You'll know which one they want based on the answer options. So you have to know how to go back and forth between both. I'm ready to make some changes already to the CP chart. Look at the screen. Shouldn't be looking at each other. All right, so relative frequencies would be a portion of the data set each category in a frequency table makes up. There's a few different kinds. We'll briefly talk about those. But when you hear that phrase, you should automatically be thinking decimal or percent. So for example, Tanisha conducted a survey at school. She asked 80 randomly selected students whether they preferred basketball, football, or soccer. And here's her data. If she was told to make a relative frequency table, so you'll have entire tables with relative frequencies. Then it would be an entire table with either decimals or percent. They usually will not show you the work that they did to get there. You just have to know that's how they got there. So then for football, what would the fraction be? 32 over 80. That's how many said they liked it. And this is how many people total that were surveyed. So yes, soccer is 28 over 80, but that alone won't be my answer. We're just showing you how they're figuring that out. If you want to write it each time, that's fine, but when you make a relative frequency table, it should really just be the decimal or percent. So what's the decimal for 32 over 80? Don't say it out loud. Table 7, what is it? 0.4. 0.4. Just put it in your calculator. Fraction bar means divide. So 32 divided by 80. And since this one has 2 decimal spots, I'm going to put 2 decimal spots on there. Now, what about for soccer? Table 8, what's the decimal? Well, that is right. And then what about for 80 over 80, class? 1. And then again, since we're doing 2 decimal spots, I'll put the zeros. Should my total ever be anything other than 1? It shouldn't. It should always be 1. So, and this would be our grand total, this was the number of people surveyed. It would be different if it was like a row total or a column total, it might not be one. But if you add the totals, it should equal one, does that make sense? Should I ever have a relative frequency bigger than one?
No.
No, that must mean that you rounded wrong or something, but should add up to one, good? Sometimes they would rather the percentage, do you know how to go from decimal to percent? Well, that is true, but then you do what with it? So that is right too, you could move the decimal 2 places to the right. In my opinion, I think multiplying by 100% is the easiest to remember. Versus moving the decimal spot, because then it's like, what way, how many times? Just multiply by 100% if you want a percentage. If you don't, divide it by 100%, that'll cancel out the percentage. I think that's easiest to remember. So then, table 5, what's the percentage for football? 40%. Table 4, what's the percentage that like soccer? 35%. And for the total, table 3, it should be. Okay, good. Any questions? Should my grand total ever be bigger than 100%? No. Okay, question? All right, this part we're gonna fill in just because there is like one question on your practice that asks what type of frequency is this? So first one's gonna be joint relative frequency. And the second one's going to be marginal relative frequency. These two, I would not necessarily star or highlight, but just, I know on your practice, it'll ask, so I'll tell you. When you think of joint, I think like joint bank account, where there's at least two people contributing at once. So joint relative frequency would be 2 specified characteristics at once. So like girls that like soccer. Boys that like football, 2 categories at once. Marginal relative frequency, I think of margins, like on your paper, it's like the edge of your paper. This would be the edge of your graph. So at the edge of my table, like here, what's always at the edges? Totals, like for that row or column. So in that case, marginal relative frequency would be when you're dividing your row total or column total by the grand total. And it says that all right here. Again, you don't need to commit these 2 to memory. Just when it talks about it on your practice, that's what it's about. Not hugely important. Questions on that? Okay, we're not gonna fill this out. I think you guys can fill out a table. Questions on the vocab? Okay. So then sometimes it says, look at the relative frequency table, make a relative frequency table. It would just be wanting the decimals or percent. All right, so if it gives you that my total for this row is 0.45, and then there's these other decimals, then what decimal goes here? I have to do the math. Do the math, don't just get. Well, that's another way too. Because 12 plus 18 is what? 30. And then over 80, give me what as a decimal? I found a very thing. 0.375. I heard 0.75 and I was like, there's no way that's more than 75. All right, and since these are to 3 decimal spots, this one isn't, but you can make it 3 decimal spots, like a 0. Then I would round consistently, the way that they're rounding. All right, so you could do 0.45 minus these and get the decimal, or you could do the numbers divided by the total. Get the decimal that way. All right, so relative frequency tables, you should be thinking of decimals or percents. .75? Is that what you?
That's the total of those two. That's not the right.
Oh, okay, yes, yes. Yes, you're right. So if this is 30 and this is 36, how many girls like basketball? 6. And then 6 divided by 80 is. Okay. Earlier, I was getting confused because I thought you said 0.75. Which I was like, that's way too big. But 0.075 does make more sense. Sorry, I don't have an answer from my friend. I just rely on you guys. All right, questions? So then fill in these missing pieces. Either with the numbers, like how we did, 44 minus 10 minus 14 divided by 80, or just subtract the decimals. As long as you get to the right answer, it doesn't really matter. So fill in these parts with your decimals, because the rest are in decimals. It's the same. All right, so regardless of how you did it, maybe you focus more on the totals, like the numbers, not the decimal parts of it. But regardless, like they should all add up. Like if you did it just based off of the numbers, 14 plus 20 plus 10 should equal 44. 0.175, 0.25, 0.125 should add up to 0.55 and vice versa. Questions on that? All right, so if it said, what's the relative frequency of people that like football, what would you say? 0.4, good. What if I said girls that like football? You would say? 0.15. So also knowing where to look in the table. But relative frequency, your answer should either be decimal or percent. Good. Relative frequency tables should be all decimals or percent. Tells you like basically what portion of people that were surveyed said that response. So you can see a lot of people said, or a lot of the people surveyed were boys and things like that. A lot of people said they liked football. Questions on that? Okay, so there's that. Don't think we need to do the rest of this page. Let's look on, or not let's look on. I want you to go to the back side and add in this vocabulary. Because this one I did see on the quiz that I kind of give you later. Not this week, next week. Okay, so conditional relative frequency is another type of relative frequency. So you should automatically be thinking decimal or percent because it says relative frequency. And usually the question won't say, oh, what's the conditional relative frequency of blah, blah, blah. It usually won't say that. But the difference between that and the other type of relative frequencies is what you're dividing by. So you're essentially not dividing by the grand total. It's found by dividing a frequency not in the total row or total column by the total for that row or column. which will make sense when we're using it. All right, so if we go back to Kanisha's survey about the different genders and what sports they prefer. So like this would be a good test question. Out of the total students that prefer soccer, how many are boys? And what's the relative frequency of that? So here's the table down there for reference. How many boys prefer soccer? 10. There's 10 boys that prefer soccer. Now, relative frequency, because it's a decimal or percent, we're going to make a fraction, right? This is going to be out of the total students that prefer soccer. So how many students prefer soccer? 28. How will I set up my fraction? Will it be 10 over 28 or 28 over 10? Should my relative frequency ever be bigger than 1? Bigger than the number of people that were surveyed? It should not. So it should be 10 over 28. So the difference in this is that we're not dividing by the grand total. It's just out of the total that prefer soccer. Does that make sense? So then 10 divided by 28 is a long decimal. We'll round it to 3 spots. 0.357. Right, 0.357, or what would that be as a percent? 0.357 as a percent. 35.7%. This times by 100%. Good there? All right, so you'll see questions like that on your test. Really just read them carefully. Like all vocab aside, you don't need to memorize the vocab except for relative frequency to know that that's decimals. But all vocab aside, you just need to read it closely. So now you try quietly yourself, don't call it out. So in that same survey, which is up here, out of the total girls surveyed, what's the relative frequency that they prefer football? Calculate that, put it on your paper. I'm gonna pass out your practice while you do that. Table 2. So how many girls were surveyed? Table 2.
Like 36.
36. Would that be my numerator or denominator? All right. And then table 1. How many of those girls prefer football? All right. Anyone disagree with how it's set up? So you really just have to read carefully. Out of the total girls surveyed, so dividing by that total, what is the relative frequency? So you're going to want it to be a decimal that they prefer football. So know what numbers to use, should never be bigger than 1. All right, so then 12, well, when I say, I mean your final answer should never be bigger than 1, the relative frequency. So if it's 36 over 12, you know you did something wrong, so that decimal would be bigger than 1. So then 12 over 36, what's the relative frequency? Good, and then as a percent would be good, and it just depends how your answer rounds. But any questions? Simple enough. So I'm not making you like necessarily memorize vocab except for relative frequency. That must be a decimal or percent. All right, the practice is a worksheet. I don't think it's very difficult. I think you could get it done in 10 minutes. But I will be checking it Monday right at the beginning of class. We'll have it out and I'll come around with my clipboard before we go over any answers. So feel free to ask questions. You could get it done like right now and then not have homework this weekend. So if you can't trust yourself to not lose it, you can show me and I'll write down your score. But otherwise you could also upload it to Schoology, but I will check it Monday right at the start of class.